Hello everyone, my name is Alex. Welcome to my presentation today about AI in the browser. We're going to be discussing about how can you predict user actions in real time with TensorflowJS. Well, a little bit about myself. I am from Bucharest. I'm 25 years old. I work as a senior software engineer. I work mostly in front-end and back-end, but I also have a passion about machine learning, about artificial intelligence, and about everything related to modern technology and how can I integrate that modern technology to my day-to-day work and life. Well, and I will be trying to share with you today some of these insights. How can you integrate AI into your day-to-day work, day-to-day life, and into your customer's life? So first of all, what are we discussing today? First of all, what? What is machine learning? How it works? Is it really that magic as they're trying to show it to us? We'll find out. First, second, why? Why are you attending this presentation? What can machine learning do for you? We'll find out. Then how? How can you add machine learning to your web application? I think this is exactly why you are here, but anyway. And then you're gonna be seeing some examples. This is actually why you came. So, what is AI? What's machine learning? And all those fancy names? Anybody wants to take a guess? Okay, I'll give you 10 seconds. I think everybody knows about AI and machine learning. Come on, let's be honest. So, machine learning is a subfield of artificial intelligence that uses algorithms trained on datasets to create self-learning models. This is quite a mouthful, but you know everybody knows what it is. These models enable machines to perform tasks that would otherwise only be possible for humans, such as categorizing images, analyzing data, predicting price fluctuations, and other things. Well, those things are pretty hard to do in a classical way. Let's say, for example, categorizing images without a machine learning, it's, I won't say impossible, but really, really, really hard to achieve. Let's be honest, try to create an analytical project that will do that. Try to use ifs, fors, whiles, and other classical control flow structures. Try to use them. And try to categorize an image. Tell me if in this image it's a cat or a dog or it's a human or whatever. It will be really hard to do it. So this is why machine learning was invented. How it works. Let's say that I have a training data set with 10,000 images of dogs and 10,000 images of cats. If I ask you right now which is which, obviously you know which is a dog and which is a cat. Why? Try to take a small break, a few seconds, and tell me why the top one is a dog and why the bottom one is a cat. Because you know. You know it. Why? How do you know that's a dog and a cat? Did you stop for a second and looked, the one from the top has bigger teeth, the one from the bottom has cute eyes, the one from the top has ears pointing down? No, you didn't do that. Let's be honest. You just saw the image with a dog and you knew it's a dog. You saw the image with a cat and you knew it's a cat. How? Well, probably didn't thought about it, but you know because you saw them before. You know how a dog looks like and you know how a cat looks like. Without analyzing the image, you're not spending time to take each pixel and see how it looks like. No, you know how a cat looks like and how a dog looks like. And this is why I thought it would be really hard to write an analytical project, a classical project to do this. So, why are we here? For machine learning, of course. Well, we're gonna be feeding those images as training to our model. Our model will be training. And while the model is training, we'll be waiting and notifying it and watching it. Well, you'll see later that these are called training epochs, but you'll see later in the examples. Right now you have to believe me. Then we're gonna test it. We're gonna feed him some 100 more images. Cat and dogs, mixed. Which one is which? Which is the left one? It has white fur, the other one also has white fur. Oh my god, I have a headache. Which one is which? I don't know. Me, as a person, I know. But the model will know or not. I don't know. They will find out. And you'll be giving those 100 images. And out of 100 images, let's say the model managed to categorize 80 of them. If 80 of them were correct and 20 were wrong, because you know the labels already, you feed him also the labels, but you want to look at them until after the computation, then you'll be able to find out the accuracy. If you have 80 wrong, 80 right, and 20 wrong, the accuracy is 80%. Just so you know, as a side note, an 88% accuracy is quite decent. Just so you know, everything above 70 is considered pretty good. Usually for very high performance models, you will go to about 90, but the example that I gave you is quite okay for a production model. Let's say that you have the accuracy of 80, you are happy with it because let's say the requirements were like minimum 60%. Now I'm happy, I can go and use it. Good, so looks simple. Have a nice day. Now, wait, don't leave yet. So let's talk about machine learning models. I told you about that thing called a model. What is it? Well, the most used machine learning models. First of all, we have the linear regression. This is the most basic type of machine learning. Let's say you have a function, y equals 2x plus 1, let's say. This is a function. And do I know this function? Yes. Does the computer know it? No. So I will be computing 5 points on this function, let's say 0, 1, 2, 3. And in each point, I will compute the value of the function. What am I doing then? I'm going to feed the computer the data. I'm going to tell him, in point 0, the value is 1. In point 1, the value is 3. In point 2, the value is 2 times 2, 4, plus 1, 5, and so on. And I'm going to tell him, guess the function. Well, but he won't really guess it. He'll be approximating it. He'll say, I have these points, I will draw a line between them, that's the function. Quite straightforward if you ask me. And then whatever data I give it, it will try to predict it. Then I have the decision tree. The decision tree is used for classifications, not for regressions. Let's say that I have the example with the cats and dogs. If I give him three examples only, and one of them is a white cat, the other one is a brown cat, and the dogs are all black, let's say, in my examples, then the decision tree will look something like this. Is it black? Yes, it's a dog. It's not, it's a cat, obviously. This is a very huge simplification. This is why you need to have thousands of images and labels and other things for processing, because if you don't do it, you have very, very long results. But this is just an example. But the decision tree has a small issue, if you're asking me right now. The decision tree is very prone to mistakes. So this is why we have another structure built out of decision trees, which is called a random forest. You know, a collection of trees in nature is called a forest also. So we have 100 trees, and each one of them will give a result. What will be then the result? Well, the majority will decide. If we have 70 of them who say cat and 30% say dog, then it's a cat. Democracy, majority wins. And then we have a neural network. What is a neural network? Well, this one is a bit tricky right now. This one is no longer going to rely on classical approaches. I told you in the beginning that you know which one is which. You know which is a cat, you know which is a dog. Cool. How? Did you took each pixel and analyze it? No. Did you build in your brain a model to say, is it white, is it brown, is it black? No, you didn't. So how did you know that? Think a bit about it. Right now, let's say something else. You are walking down the street, you see a car coming towards you. What do? You jump left, right, you run away. You do something. Did you have time to think about it? Did you say, oh, there's a car. What am I doing now? Oh, I need to, what? To run, right? No, you don't do that because you'll be dead. You know already. You see a car coming towards you, you run. You know it in an instant. How? Well, there are thousands of processes happening inside your brain in order to reach the thought. And this is what the scientists have been studying, the human brain. The human brain is composed out of neurons. This is what is called a neural network because it's built out of neurons. A neuron is a very, very simple structure inside our brain, or in this case, inside the machine's brain, well, which will just do a simple function. You say, oh, cool, so it's just a small program. Yeah, a neuron is just a very, very basic function. And how many of them do we have inside our brains? Billions, trillions. There are a lot of them. You have so many neurons that you can count them. Only with a very powerful microscope you can do it. So how do our thoughts appear? How do our feelings, our emotions appear? I don't know how to tell that because I'm not a doctor and a lot of people actually don't know that. But I can tell you how the machine thinks. You have the input layer. In my example, the input layer is that a car is coming towards you. Something happens in your brain. There's a hidden layer that you don't know about. And then through the output layer comes your decision. You run away. How that happens, you don't know. There's the same thing the way this happens in machine learning. In a neural network, you know the input layer, the hidden layers, and the output layers. Their connections, how they are talking to each other, it's not your business. It's the network's job to do it. So what we're going to do is the following. You're going to be defining each layer, and you're going to be leaving them optimize themselves and build relationships and other things. And at the end, if you're happy with the accuracy, you'll be able to move forward. If not, you'll be retraining the data. So now that I gave you the examples, now why are you here? What can machine learning do for you? Well, a lot of things. Predictions, classifications, content generation, recommendations, a lot of things. Let's say you want to predict the next value of the New York Stock Exchange. Right? If you manage to do it reliably, you'll be rich, and you won't be attending my conference because you already be too rich to work. Well, let's say you want a classification. You want to tag an image. I told you, I showed an image of a cat. How do you know it's a cat? That's classification. That's a classifier model. You want content generation. I won't even discuss this because it's about ChatGPT, large language models. I think you heard enough of them. I won't be even opening the subject because you know too many of it already. And then you have recommendations. What are recommendations? Well, recommendations are when you go to Facebook, to Amazon, to whatever website, and you see if you are on Amazon and you are searching for a specific product, they might be asking you, are you also interested in whatever, or on Netflix, or on any other application? If you watch a specific movie, it will say, don't you want to also look at whatever other movie they have there? Because in the same category. This is what a recommendation is, actually. Now, real life examples, we have a lot of them. Chatbots, voice recognition, facial recognition, product recommendations, autonomous vehicles, fraud detection, security optimization, sentiment analysis, data extraction, pathfinding, image processing. Unfortunately, or not, the list of AI use cases is expanding so rapidly that we can't keep up with it. You see that everything has something with AI in it right now. It's a trend. You want to make money, you need to put AI in your product. Is it a good trend? I'm not smart enough to tell you that, but if you're asking me, you should be thinking if you really need AI, or you can do it with a simple approach. But who am I to tell you that? So I think this is why you actually came here, not for the theory, but for the practical part. How do we do it? How do we implement AI in our application? Let's go ahead, TensorflowJS, that's why we came here. Well, you can scan the QR code or just go to the URL or just search on any search engine that you're using from Google or whatever, search TensorflowJS and you'll find it. So what can TensorflowJS do? It can use existing pre-trained models. It can retrain existing models. It can also develop a new model from scratch in JavaScript. This is what we'll be doing. We'll be developing a new machine learning model in JavaScript. We'll be quickly training systems that use classical machine learning models, regression, decision tree, classifier, neural networks. You can easily adapt existing models that are trained on large-scale computers in Python, in whatever other languages, and can adapt them to JavaScript, and can run 100% in the browser. Yes, you heard it right. You can do a machine learning algorithm 100% in the browser, no server, no Python, no other libraries, nothing. Just a HTML and JavaScript file. That's all. It's already used by Google, Adobe, LinkedIn, Hugging Face, and a lot of other companies. I won't even be getting into the subject. So, I told you I want to predict the value of the stock market tomorrow. Spoiler, don't open your trading platform and start using my example because you won't get rich. It's just a very basic example here. Don't use it in production. So first we import in TensorflowJS. Import star STF from TensorflowJS. That's classic. Obviously, I forgot to tell you here, but it's common sense that you also need to install the dependency first. npm install TensorflowJS. So we define a sequential model because the data in the stock exchange is sequential. Each day we know the value of the stock exchange. Const model is TF sequential. Then we add hidden layers to the model. I told you, input layer. Remember this. Keep this picture in your head, please. Input layer, hidden layers, output layer. Please try to keep this in your head for a second. So now we had the input layer, which is the data of the stock exchange. Now we're adding hidden layers. We're adding layer model.add TF TensorFlow layers dense. It's a dense layer. I won't be giving you too much explanations what is a dense layer. You can search in the documentation, but you have to remember here two things: units and input shape. Input shape means what is the shape of the value that I give to it. Is it an array, a matrix, or whatever? Input shape 1 means it's just one value. And units, how many units of that layer you want, basically. Now I'm going to be compiling the model. Well, we're going to be using two parameters, loss and optimizer. Don't stress if you don't know what they are. I will explain them a bit in a few seconds, actually in a few minutes. But Basically, that's what we do right now. We compile the model, just like it's a normal program. You write the source code and you compile it. So what you do then? You run it. Well, in machine learning, we have one more thing to do first. We have to give him data. What data? Training data. Let's say that for the value of -1, the function takes the value -3. Whatever. I told you this is not really the stock exchange, but you can adapt it to a stock exchange if you want. Let's say that the function in point 0 has value -1, for point 1 has value 1, and so on. Also, there you see the shape. You can see the shape of the input here, 6, 1, which means it's an array of 6 elements and 1 dimension. It's not a matrix, it's just a simple array. And you also have here the values that the function is taking. So after you train the model, you say fit this data. You see a parameter there called epochs. Epochs means how many training sessions the model will get to. Please bear in mind when you define the epochs, don't use 2 epochs because you have horrible results. Nothing will work if you use only 2 epochs. You won't be able to train it. And don't use 2 million epochs because your computer might start burning. You might end up shopping for a new computer. Or not, but at least you get a freeze. And you don't want this on the client's website. After that, you'll be using the model to predict the value of the function in the specified point. You predict TensorFlow2D in the value 20, let's say, in the point 20, which is the value of the function. Well, right now, this is how we could adapt this to real life. And let's say I want to know what is the value of the stock market from New York, from Paris, from whatever other city. What is the value of that stock exchange in 1 month? Like, should I buy it? Should I not? Well, obviously, this is just prediction. But this is what you could adapt this model to do. So this is how it looks like in the memory of the computer. It will get the data. It will say 1 point is here, 1 here, 1 here, 1 here, 1 here. What do I do now? I draw a line between them. I don't know the initial function. The initial function was 2x minus 1, for which I gave the data. I think you recognize it pretty quickly. In point 0, you have -1. In point -1 is -3. Then in 1, it's 1, and so on. Okay, and so on. After that, what do I do? Well, the computer will stay. Okay, and think. I have those points. I need to draw a line between them. I draw a first line, like this. Is it good? No. I draw a line like this. Is it good? No. Like this? No. Like this? No. Like this? Whatever. And after a few iterations, that's why I told you need a lot of epochs to train it, you'll find out a line that passes through the points with minimal losses, with the best accuracy. And you'll say, that's the function. I guessed your function, only by looking at the points. If I would have told you right now to guess the function, well, just looking at it, it will be like, it takes me a while. Well, computers are pretty good at doing this because it means doing a lot of operations in a limited time. They're doing a lot of simple operations here, which they are good for. So what I want to propose to you today in the context of front-end development is to build a machine learning model that will be a next page prediction system. Basically, given that the user is right now on Facebook, on Amazon, or whatever, on an application, you're on a page newsfeed. You click from newsfeed, you scroll to it, you see a post from, I don't know, the Washington Post, the Kiev Post, the whatever website you're reading. And you see the news about Mercedes launched a new car today. Okay, nice. And then you scroll a bit more and you see an offer for that car. Wait, why? Why did you saw that? Well, because the application knew that if you saw an offer for something, well, obviously if you see an offer for a car, it means you are quite rich, but that's something else. If you see an offer for a specific thing, and you might want to see more about it. The application saw that from the past 1,000 users who saw that article, 20 of them search online for that model. What if I show you already that ad? Well, this is one use case. The use case is pretty annoying for us as users, but pretty good for the business owners and for the developers. I give you a more constructive approach right now. Something that will be good both for the developers, for the owners, and for the users. Let's say that you are in an application and you always go from newsfeed to messages, and from messages somebody is texting you that you want to do whatever, And then the page that allows you to do that action will already be loaded. Will already be there in the memory, and we want to click it, it will load instantly. Can you do that? Yes, of course, you can prefetch it. But the question is, how do I find out which is the next action of the user? This is what I'm going to find out today together with you. I want to build this model with you. Given a scenario. I'm in the page called home, then I'm going to newsfeed. From newsfeed, based on my history in that application, I saw that I usually go to messages or reels. From messages, I go to marketplace, to newsfeed, and from newsfeed, you restart the flow. Also from reels, I'm going to messages, to events, to whatever. So the question is, the user goes to home, newsfeed, messages, marketplace, newsfeed. What's next? You will have to find out. The machine learning model will have to find out which is your next action, and use that to predict some actions, to load some things, to show you an ad, or other things like this. How do we do that, actually? Well, first of all, let's use a model, a machine learning model. Which one? We have linear regression, decision tree, random forest, and neural network. I told you, those are the most basic ones and some of the most used ones. I'm not going to very advanced models like large language models or GPTs or other things. No. Let's keep it simple because we're doing things in the browser. It's really hard to use a large language model in the browser. And also we don't have the knowledge to do that. We're just at the beginning. So why should I use a linear regression? It's simple, it's performant, it has good accuracy on regressions. Nice. Why shouldn't I use it? Well, it assumes linear relations, it oversimplifies real use cases, and it's really prone to underfitting. If you just give a linear regression 2 points, 0, 0, and 5, 10, it will say, oh, I can draw a line between them, and that's it. I have the model. Well, 99.9% of the cases, that is horribly wrong if you do that. So this is why underfitting is a huge issue for the linear regression. It tends to oversimplify things. It assumes everything is just a line, which is not true in real life. Almost nothing in real life is constant like a line. So we have another option with the decision tree, where it has a minimal data preparation. I just give you the raw data. It's very strong when it comes to classification tasks, like I had that example with the cats and the dogs. Nice. But I don't want to define which is a cat, which is a dog. I have a pretty complex use case here, not really just classifying which is which. So there's the issue, as I told you. The linear regression is prone to underfitting from too few data. The decision tree is prone to overfitting, which means that if I give him too much data, there's an issue, there's a catch with that. You shouldn't give him too much data. If you give him too much data, you remember the image from a few slides ago, that the decision trees are just branches going from one to another. Well, if I give him too much data, you will see that he will build too many branches and start getting lost into them. And he will start throwing random things there. It's very unstable to noise, which means that you should be careful with how much data you give it, and give non-continuous results, which means that it cannot guess things. It only has a predefined number of states. And this time I don't want, because I want to guess the next action. So you already understand that decision tree is something that we won't use today. So we have the random forest. Random forest tries to actually fix some of the issues that the decision tree has. It's a collection of trees, I told you. It has high accuracy on classifications, it's quite versatile, and can handle missing values, unlike the decision tree. But, there's a but, it's prone to overfitting, just like its children, the decision tree. It's very slow at predictions. It has a huge memory consumption, because just think about it. You have 100 trees, each one of them in your memory, each one running in parallel, voting, consensus, counting the votes. No, that's a big no for me in the browser, but you can use it also in the browser for some things, but for our example, it's a bit too much for us. And on complex models that are assuming nonlinear relations, it's quite bad on accuracy. And again, it's built for classifications, not for guessing. And we have a neural network, that black box, that magic black box that I told you about, that can capture complex relationships. It doesn't really have a mathematical formula in it. It has a collection of neurons that do God knows what they are doing there, and has the ability to learn by themselves. Well, disadvantages, of course, there are. It might require a large amount of data to effectively learn complex patterns, and it's very hard to debug because it's quite of a black box nature. So, which model do we use? I told you from the beginning I don't like the decision tree for this task. If I was doing the task with cats and dogs, obviously I would have gone through the decision tree or the random forest. But since we are not doing classifications here, we are doing predictions, I don't really want to use that. And also I'll be cutting the random forest because I told you it's a superset of decision trees. So which one are we using? Well, I will go with a neural network because it's a bit more complex. It solves the issue and it's quite used in real life. So I want to give you a more complex example. I'll also give an example of the linear regression, but that's too simple for the presentation. So what do? First, we gather the required data, we transform the data for training, we initiate the model, train the model, and do the actual prediction. Let's start working. How do we gather the data? For any navigation the user performs, we will store the data in an array. Handle page click, and when the user clicks on a specific element in the page, we'll just push the data into an array, in my case here. In real life, we will be storing it in a database in something like this. But in my case here, I'll give you the code for this so you can run it in one single file in the browser. You'll be able to run this model by yourself. So, since the training data is now different, it means that the model needs to adapt to it. So you rerun and retrain the model. How do we train and run the model? Well, think of this as a pseudocode. It's actually taken from the code, but right now you don't know what each function is doing. We'll take them in private and discuss each one of them in particular. So first we transform the data. We put it into some type of data set. We initiate the model, we train the model, and once the model has been trained, we then predict the next page with the newly trained model. So how do we do this? First, transform the data preparation. Well, most machine learning models, especially the neural network and the linear regression, don't work well with strings. I can just give him an array of strings like the numbers, like the name of the pages, home, newsfeed, messages. No, that's a big no for them. Instead, they work perfectly with numbers. So I'm going to map those pages to actual numbers. I will say page home has ID 1, page newsfeed has ID 2, page messages has ID 3, and so on. Passing those numbers up to the model. And that's basically what I'm doing here. I'm creating a tensor from them, a tensor filled with zeros, which is basically just a vector. If you want to think of the tensors right here, this is why it's called TensorFlow, because the layers of the model are passing from one to another tensors, which are overglorified vector, an array. They're basically arrays, but with some specific properties inside the model. But we'll be considering them arrays for us. So now we need to compile the model because we gave him the training data. We gave him the history of the user. So how do we do this? This is the most tricky part here. This is the most important part, the initialization of the model and also the training. But first let's discuss this. We have the model, which is a sequential model. Why it's a sequential? Because the data is coming one after the other. We don't have holes in the data. It's like the example of the stock exchange. We know each action of the user. So defines a sequential model with 2 layers. Obviously, you can add how many layers you want. It might increase your accuracy. It might, but it will also require a lot more computing power. So think twice before doing this. But obviously, if you want, you can play with it and see. So first of all, I'm going to add a dense layer with 8 units. And input shape is the shape of the array that I'm sending. And it has an activation function. The activation function, here, rel, softmax, whatever. I have a lot of them. Rel, gelu, softmax, whatever. The activation function, you can search online about them because there are a lot of them. Is the function that will tell each neuron from the network, hey, listen up, it's your turn, come on, give me the result. That's the one that will call the neuron and say, yeah, your result is good, give me the result, pass it to the other one. Well, I'm using 2 of them here just to showcase them, but you can use more of them depending how layers you have. And also you have a lot of other options for these ones. You can read online which function is the best for your use case. You can ask on forums, you can ask ChatGPT which is the best activation function for each case. It's quite a lot to read about this. So I'm only telling you what you can customize here. You might have seen here that you have then the compilation of the model. Once you defined it, you have to compile it. In the compilation, you have an optimizer and a loss function. Well, you have Adam optimizer here used, but also there are a lot of other optimizers that you can use. You can search online about them. I can't discuss to you about this right now because I will need like 2 hours to present you all the optimizers. you also have the loss function. The loss function tells you during the training, how do I compute which is okay and which is not from the results, basically. How much I'm losing for each prediction, how much accuracy I'm losing. There's a loss function. And which metrics I'm using, well, obviously the accuracy in my case here, but there are other metrics too to use. This is basically how I'm initiating and compiling the model right now. Now I have a model, but it doesn't know how to do anything. It's built, it's there, it's in the memory, but it's dumb. It has no idea how real life works, how it works, how everything works. So what are we going to do with it? Treat it like a small baby, like a newborn child. The brain of the child, the child already has the brain. That's nice, but it doesn't know how to do almost anything. You need to teach him how to do it. In the first years of our life, our parents are teaching us how to do that, what to do, what not to do. Treat your model like this, like you are teaching your baby a lot of things, like you are training a dog, let's say. You have a newborn dog or a cat and you want to train it. It doesn't know how to do anything. It can't even sit by its own. So you need to train it and tell him, this is how you sit, this is how you fetch, this is how you give the paw, this is how you do all the things. So this is exactly like now. We have the model, it has the brain, but its brain doesn't know how to do anything. So I'm training it. I'm giving him the history of the user and I'm telling him, train on this one. So how do you train on this one? Well, it's pretty simple. I'll tell you for each page, when the user went to this page and this page, then he went to the other page. So build in your memory the model, optimize the model to do this, to predict such a scenario. Okay, and he will say, I'm trying. And you give him the epochs and the batch size. Where the epochs, I told you about them, try not to give a too big number, but never give only 2 or 3 epochs because you won't do anything. And the batch size means how many batches to take and how many batches to split the data. Use a decent number here too. So how do I predict the next page now? Well, I'm going to convert my user history into an array, into a tensor basically. So I'm going to use tf.tensor2d. Tensor2d means an array transformed in a tensor. You see here. And then I'm going to predict the page. How? I'm going to call user history is create empty tensor. I'm going to create that empty one. And then I'm going to predict based on the user history. So what am I doing here is that I'm giving him the user history, passing it as a tensor, and then I'm going to give it to the model and say, argument max of 1 from the predictions, which means the first prediction, the top prediction, the one with the biggest score, because you will see here in the predictions, if you do a print on the predictions, you see that it will not only give you the favorite response from the memory. Now it will tell you 50 neurons said it will be answer 1, 20 neurons said answer 2, and 10 neurons said answer 3. So which is the answer? Well, you will take the one with the highest majority, which is 1, the one with 50. This is what you're doing here, basically taking it, data syncing it, and you're taking the first prediction, the one with the highest percentage. And that's basically it. Now you have the prediction on what the user will do. Obviously, this is just a very simple model to show you the concepts, to show you how you can implement this, and to show you that it's not really that hard to build your own machine learning model. You have the full code here. You can scan the QR code right now if you want. I'll give you a few seconds with this page. Or you can go to github.com/myname/alexhank/nextPagePredictor. You have there an example. It's everything put in 1 or 2 files, one simple HTML file with TensorFlow taken from the CDN, and you can just run it in your browser instantly. So just to give you some time to scan the QR code, we initiated a model, we navigate somewhere, we process the data, we train the model, we use it for prediction, and we print the results. That's what we do. But I told you something else. I can also use a regression here, which is a simpler model. So instead of training the data with all those layers and other things, I can do something else here. I can use a regression models, which are way less accurate in our case, but they're faster. So is it worth the trade to give up some accuracy for performance? I don't know. You should tell me depending on what you want to use it. So this is how you do it. You compile it with mean squared error, use optimizer SGD. You only have one unit in the layer. Yes, you only have one dense layer. And what you're going to do, you're going to do the following. You're going to be using fit, x, y, and you're going to be passing the number of epochs. You'll say, do 100 epochs, compute that function however you compute it, and try to predict the user actions with that function. Will it work? I don't know. Probably not as good as a neural network, but you can give it a shot. And if you are happy with the accuracy, you can go with it because the performance is way better. So I tell you, if I would have to choose again, I'll also use the neural network. But if you'll call what you want to choose here. Some other examples from TensorflowJS on what we can do. You have a question and answer bot, a chatbot basically. You have speech recognition, like you are talking and he will try to transcribe it. You have toxicity filter, which is used for various social networks. When somebody starts saying bad words in an online conversation, he'll be blocked from a specific, his post will be hidden or something like this. You have GPT-2, which is the grandfather of the current large language models. The first LLM that got popular was GPT-3. You have GPT-2 on TensorflowJS, and you can actually run it in the browser if you have enough RAM memory. And you also have there an example with face detection. You see it there on the link that I gave you. So that was basically it for my presentation. Thank you very much for attending it. If you have any questions, please don't hesitate to ask them right now. If not, you can also find me on my email, alexanderhanga@yahoo.com, and on my website, alexhang.com. And please, if you have any questions, I am here. I'm happy to respond. If not, you can write me in private. Thank you very much for attending it. Have a nice day, everyone. Bye-bye.
Thanks, Alex, for a very informative and highly relevant topic at the moment. It was really interesting.
Thank you too.
So I think the first question which came to my mind while we are waiting for any questions from the audience is like, are there any performance limitations you might face with ML in browser? Because it sounds scary.
Yes. Yes, that's the biggest issue. This is why I also say that we should be careful when doing this. We can't really train large models. We can only use simple ones when we're talking about this one. Because you see why the large language models, and not only large language models, any other model is being trained on a server with thousands of terabytes of RAM and thousands of GPUs. That one has almost unlimited memory. While here we have like, I don't know, 8 gigabytes, 16 gigabytes of RAM and a basic CPU. So, and also we don't want to stress them. So yes, there are a few limitations, but for simple models, we can actually do it, and it will be actually faster than sending the data to the server, processing on the server, and then bringing it back.
Okay, see, thanks for this. And you mentioned that with TensorflowJS, you can create some custom models. So when it makes sense to use something existing and when it makes sense to write something from scratch. So maybe you can.
Well, there are some moments. Yes, there are some moments when you can, for example, take a model that was already trained by somebody from TensorFlow or from the examples or from something that you built and trained on the server. But there are also examples where you can build your own model for use case that hasn't been used until now, hasn't been found. I don't know, maybe you have $1 million idea that was never implemented. I don't know. Maybe you have it. So then you have to build everything from scratch. But in most of the cases, I'm pretty sure that a basic one that you can find on the internet or anywhere else could be okay for you. But it's also supposed that, yes.
Okay. I see. Okay, thanks. And maybe the last question from my side. So how to start with machine learning for people like who do not have any AI related background? So maybe you can recommend some resources.
Yes, what I recommend is to just search online for some tutorials. You also have TensorFlow tutorials if you want to start with TensorFlow, but there are some other tools like Keras, like SciPy and some other ones. But most importantly, try a bit to understand the principles, because no matter the framework that you use, it's just like in any software development. It doesn't matter what framework you use, you need to understand the concept. So try to understand a bit online what is a regression, what is a classification, what is a linear regression, what is a decision tree, what's a neural network. Once you understand those things, you can easily deep dive into basically any framework that you choose.
Okay. Thanks, Alex, one more time for your presentation. It was
Thank
really
you for
insightful.
having me. Thank you
and as
very
I
much.
said, relevant.